And the third speaker of our session, if I remember correctly, is from Hong Kong Baptist University, so not so easy, unfortunately, to join us in person, but is joining us remotely. So looking forward also to this talk in Beyond Accuracy Measurements, looking at things like personality and how these map in not just getting the recommendations right, but actually making sure that they're useful. Please take it away when you're ready.
Okay, hi everyone. Thank you for being here. And I am Ningxia Wang. I'm proud to be here to present our paper titled User Bias in Beyond Accuracy Measurement or Recommendation Algorithms. This work collaborated with my supervisor, Dr. Chen. And as we know that biases are widespread in the recommended systems. For example, at the inputs, we may have the data bias caused by the sampling from the populations or the process of data cleansing. And also at the output, we may have the deployment bias caused by the design of user interface and the involvement of decision makers. And also during this process, we may have today the focus of our topic, the algorithmic bias, which is primarily caused by the algorithm's mechanism. For example, about the algorithm's assumptions, feature selection process, and the logics. So currently, for the research about the algorithmic biases, there are two directions. The first one is from the perspective of the recommended items. For example, the popularity bias, referring to the fact that popular items may be more frequently recommended to certain group of users. And the second direction is from the perspective of the target users, referring to the fact that users with different characteristics may receive recommendations of different qualities, even using the same recommendation algorithms. So based on the literature review, we found that first, let's work on algorithmic user bias, then algorithmic recommendation bias. And the second, the existing works on algorithmic user bias may have mainly focused on the accuracy performance of algorithms, but less on the beyond accuracy objectives. And third, previous works on algorithmic user bias mainly considered users' demographic information, but few have taken into account the psychological characteristics, for example, the personality traits of users. But currently, the research on the relationships between the user's characteristics, such as personality, with the user's perception of the recommendations, has been increasingly raised. So on the other hand, the problems of the traditional accuracy-oriented recommended systems, for example, the filter bubble problems and the echo chamber, had led the researchers to take more and more attention on the beyond accuracy objectives, such as the diversity, which is generally defined as the opposite of the similarity, and novelty refers to recommended items that the user did not know about. Unexpectedness is to recommend items that significantly differ from the profile of the users, regardless how novel or relevant these items are. And also the serendipity, which is to recommend items that are not only relevant, but also surprising to the user. Based on those findings, based on the literature review and the research hotspots currently, we are engaged in answering the two research questions in this work. The first is that do algorithms have significantly different performance among different user groups in terms of the beyond accuracy objectives? And the second is that to which extent may the biased performance lead to the unfairness to users? To answer these questions, we employed a publicly available dataset collected from a popular e-commerce platform called Taobao in China. And this dataset involved more than 11,000 users' feedback on the e-commerce recommendation from multiple perspectives. For example, the relevance, diversity, novelty, unexpectedness, and the serendipity of the recommendation. And for each user, one of four algorithms was randomly allocated to the user to generate the surveyed recommendation, respectively called the algorithms are respectively to recommend the most popular items, the relevance-oriented item, the novelty-oriented items, and the serendipity-oriented recommendations. So, and also for the user characteristics in this dataset, besides the demographic information included in the user age and gender, we also have the user's big file personality traits and their curiosity scores. To be specific, the file personality traits are respectively the openness to experience, which indicates the person's faces like imagination, preference for variety, and the intellectual curiosity. And conscientiousness indicates the planned rather than the spontaneous behaviors of the user. Extroversion is an attitude type characterized by the concentration of interest on the external object. Agreeableness implies face-like trust and tender-mindedness. And also the neuroticism is about the anxiety and hostility, depression of the user. Curiosity is the desire of the user to know or learn something new. All of these characteristics has been verified in previous work that be relevant and correlated to the user's perception of recommendations. So we employed them in this work. And so based on the statistics, we found that the demographic distributions in this dataset are basically in line with the statistics officially reported by the government. And also the big file personality traits and curiosity are not normally distributed, so non-parametric statistical methods would be employed in our work. To answer the first questions, that is, do algorithms have significantly different performance among the different user groups in terms of the beyond accuracy objectives? We conducted the man-weighting U test for the two-group comparison. Concretely, users were split into two groups for each kind of the user characteristics. For example, the younger users group and the older user group, the high curiosity group and low curiosity group. And finally, the means of user ratings in each user group are reported, and also the between group differences can show the degree of biases. We summarize the results of the significant biases with respect to each user characteristics in terms of relevance, diversity, novelty, unexpectedness, and serendipity, all of the different performance objectives. And also for the degree of the bias for each algorithms, we identify with respect to which characteristics the algorithm biases the most. But limited to the limitation, we summarize some major findings here for you. First, algorithms are more subject to produce distinct biased results between the user groups with respect to age and curiosity. And second, algorithms are more biased in terms of serendipity compared with the other objectives. And also third, for the specific kind of algorithmic user bias, algorithms that exhibit significant bias are all biased toward the same group. Now we are trying to answer the second question. Although there are with those many or significant observed biases, the reasons leading to the biases may be two-sided. The first is that the users with different characteristics may prefer different levels of the performance objectives. And the second is that the algorithm may proceed in the biased way. So to further explain the observed biases and identify the problematic biases, that is referred to the biases that would lead to unfairness to users, we further investigated users' behavior patterns. In this work, we investigated two kinds of user behavior patterns. The first is about users' historical preference by the calculating and testing the three variables listed here, and the results of Spearman's correlation coefficients between the user characteristics and the behavior variables show that first, males, high openness users, high neuroticism users, and high curiosity users are more likely to purchase items. Second, females, older users, and higher openness users have not only visited more categories, but also more evenly interacted with these categories. We believe those findings can help to explain the observed biases. For example, the behavior pattern that older users have larger catalog coverage and higher interest diversity indicates that older users may be more knowledgeable and more experienced under each category. So it may help to explain the observed biases that older users are easier to feel the recommendation relevant, but are inclined to give lower diversity ratings compared to younger users. And the second type of user behavior patterns is about the rating pattern. We calculated the percentage of positive ratings in users' ratings and compared them between groups. The assumption is that if the direction of the observed biases is opposite to the user's behavior pattern, then it might be problematic. And finally, we've identified two potentially problematic biases. The first is that high agreeable needs users are more likely to give positive ratings in terms of novelty, but actually their average ratings on the novelty of recommendations by the three collaborative-based algorithms are significantly lower compared to the counterpart group. And second is that low neuroticism users are more likely to give positive ratings in terms of relevance, but actually the average ratings on the relevance by all of the four algorithms are all lower compared to the high neuroticism users. So in conclusion, we believe that our work is the first work to investigate the recommendation algorithms biases regarding beyond accuracy objectives. And also it is one of few works that investigates the algorithm biases from users' psychological characteristics, especially the personality traits and the curiosity. Also, our methods that takes into consideration both the algorithmic user bias and the user's behavior patterns might be suggestive for identifying some problematic biases that may lead to unfairness to users. And here are some take-home messages for you. First, regarding the performance of objectives, we highlight that serendipity compared to other objectives may be more biased. And as for the user characteristics, the degrees of the observed biases are more distinguished between the user groups with respect to age and curiosity. And for a second kind of bias, the studied algorithms are all biased towards the same group. Finally, combining the algorithmic user bias with users' behavior patterns, we also notice two problematic biases for you. In future, we are interested in investigating more biases of the other state-of-the-art algorithms, and also we may combine with more user behavior patterns, as well as the social reality that is created through the social interaction process of users. And furthermore, we may develop more unbiased recommendation algorithms based on our findings and test their practical performance in the real world. cases. So that's all of my presentation, and questions is welcome. So yeah, thank you.
Thank you, Ningxia. So thank you for the very nice talk. I hope you can hear us okay. Can you hear us?
Okay, yeah, I can hear you. Yeah.
So I particularly liked your analysis at the end, and there's a question here from Peter about it, which is, which kind of biases should we worry about? Because indeed, some behaviors are typical of this type of personality. Here Peter gives a nice example. If in a recommender system, if somebody likes action movies, the recommender system will of course recommend more action movies in the future also, right? But then that's not a problem. Or if a curious user gives many recommendations, also receives many recommendations, you could say it's a bias, but it's not a problematic one. So maybe you can say a little bit more about this aspect.
Yeah, actually, we are trying to highlight that although there are some several algorithms, recommendation algorithms derived based on the theory of human personality and curiosity traits. But actually, till now, most of research are focused on the mining of user behavior patterns of the user preference for different users with different characteristics. In our work, we are trying to highlight that the algorithms based on those characteristics may be also biased towards for those users. For example, if the users if the algorithms can, for example, if the curious users prefer to more novel items than less curious users, and so it is expected that the degree of unexpectedness of the recommendations generated by the recommender system should be higher to the generated recommendations to the less curious users. Yeah, if the recommender system cannot handle this kind of differences, maybe this can it may cause some problems, unfair problems for the more curious users because they cannot reach more unexpected items that they expect to have.
And also maybe cause some overestimation. But I won't steal the floor here. There's someone waiting very patiently for the mic. Please go ahead.
No problem. Bob van der Velde, Dutch Public Broadcasting, NPO. Very interesting talk. Very interesting to see that personal characteristics, or at least self-reported personality characteristics, seem to correlate with the perception of novelty, serendipity, etc. I was kind of wondering, given that a lot of these, especially at the end, relations seem to be personality characteristic has the same direction of impact on any of these recommendation systems, wherever you've looked into the engagement behavioral patterns of these different user groups with the recommendation systems, for instance, curious users clicking on more things, clicking more back and forth, that kind of behavioral thing, and whether those kind of behavioral and activity patterns might be confounding in the analysis of their use of the recommendation systems based on their personality characteristics.
Yes, this is why we are trying to answer the second research questions in this paper, that is, behind the observed biases, there may be two potential reasons. One is from the user's perspective, that users may have different different appetites, different preferences for the attribute of the recommendations. And the other is what we concerned as the problematic, that is, the algorithms themselves may produce or aggregate, introduce the biased results into the recommender systems. So as a second part of our work, when investigated the user's behavior patterns, including the user's clicking or purchasing behaviors, and also their rating preference, that is referred to some users may prefer to use to give higher ratings than other users. For example, if in a 5-point Likert scale, some users may just use the 4 and 5 points. So in the second part of our work, we combined those kind of user behavior patterns together with the observed significant biases. And finally, if the direction of the user's biases, for example, curious users may prefer to higher level of unexpectedness, but actually for the perceived unexpectedness by the more curious users may be lower in the practical system. So we regard this kind of biases as highlighted problematic biases in this work.
So I would
also agree that more researches, more studies regarding the user's behavior patterns and the biases may be conducted to help explain the observations better. Yeah.
Okay, thank you.
Again, I would encourage you to continue this debate online. I think what we see in terms of metrics and behaviors, in terms of ratings, are not always well aligned. I see lots of questions for you in the chat that I would have liked to pass on, so please do have a look, Ningxia. But thank you again for the nice talk. Let's thank the speaker.
Yeah, thank you.
And finally, it's time for posters and coffee. Those of you that are on Team Virtual, I think you have Zoom calls that you can join. Thank you.